Hello, good people. I'm calling this video number 4, but it's the first part of the 5.9 section of Unit 5. It kind of continues our work with graphs of f and f prime and trying to connect them and making sure that we understand what kind of information we're being given. And so, just as a reminder, if they give you the graph of f prime, remember that the y value on the graph, and I'm going to say on the graph of f prime, gives the slopes of the original function f of x, right? And so when I'm looking at a graph of f prime, whether if the y values of f prime are positive, that's where the original function has positive slopes. And if the y values of the f prime graph are negative, then that's where the original function has negative slopes. And so another way to think about it is whenever f prime is greater than 0, whenever it's positive, then the original function is increasing. And wherever the derivative is less than 0, whenever it's negative, then the function is decreasing. So these are the same ideas we talked about in the other video, but now it's almost backwards. We're given the derivative. What do we know about the original function? So in example 1, we're looking at f prime. I think there's a typo here. This should be f prime of x. Now, determine when f of x is increasing and when it's decreasing. So there's several ways to do this. I've had students in the past who really liked the sign chart. And so they would say, here, I'm going to find where is the derivative equal to 0? When is this graph, the graph of f prime, equal to 0? Well, that would be right here at 2. So at x equals 2, the derivative is equal to 0. Now, what happens on either side? Well, you can pick a point on this side of 2, like -1. The derivative, this graph, is negative. So then they would say, oh, well, then it's negative here. And then on the other side of 2, this graph, which is the derivative, is positive. So then positive, 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 positive. Well, then this tells me something about the original function, right? The original function is decreasing, and then it's increasing. Decreasing, and then increasing. So I'm going to make that statement and say f of x, well, I'm going to say since f prime is greater than 0 for on x's greater than or equal to 0 for x's that are greater than or equal to 2, then f is increasing on that interval. Okay, on the second sentence, I'm going to try to make it a little bit cleaner. So because the derivative is greater than or equal to 0 on x's that are bigger than 2, therefore f of x is increasing on that interval. Let's try it again. Let's see if we can clean up this phrasing. Let's see if I can also clean up my handwriting. Since f prime is less than or equal to 0, then f is decreasing on x's that are less than or equal to 2. I don't think I like that phrasing. I think I like the original one better. Since the derivative is negative on this interval, then f is decreasing on that interval, right? Maybe that's the better way to say it. Then is decreasing on x is less than or equal to 2. So you're making the connection. You're telling whoever's grading your test, you understand that the way the derivative behaves tells us how the original function behaves, right? If the derivative is positive, then the original function will be increasing. If the derivative is negative, then the original function is decreasing. But when we're looking at the graph of the derivative, we're saying when is the derivative graph above the x-axis, because that's when it's positive. When is the derivative graph negative below the x-axis? And if I can figure that out, that's good. All right, keep going. Using example 1, does f of x have a relative minimum, maximum, or neither at x equals 2? Well, I can tell because I drew these little arrows that there's a dip here. So I can say f of x has a relative minimum at x equals 2 because the derivative changes from negative to positive. That's all you have to say. The change in the sign of the derivative from negative to positive tells me that I have a relative minimum at that point where it changes from negative to positive. You don't need to talk about increasing or decreasing. You need to refer to the derivative, since that was a graph that was given to us, and that is the calculus idea. Then we need to reference that. And you can't just say because f prime changes signs, because what if it went from positive to negative? From positive to negative, that would be a relative maximum. So I need to be specific that it changes signs, but it changes from negative to positive. We'll do one more, and then we'll come back and do some more examples. A graph of g prime. Again, I think there's a typo here. So g prime. Determine the intervals where g of x is increasing, decreasing, and determine if g of x has any relative extrema. If you want to organize your information, you can. You don't have to do this. But again, for some people, it helps to organize the information. Are there any places where the derivative graph is equal to 0? Some students would say up here, but no, that's where the derivative graph has a maximum. That's where the slope of the derivative graph is 0. But I'm saying, when is the graph equal to 0? And that happens here and here. So at 0 and 3, the derivative is 0 at those points. What happens to the left of 0? Well, to the left of 0, my graph is under the x-axis, so all of these g prime values are negative, so I have negative, negative, negative. Between 0 and 3, my graph is above the x-axis. All these graph points are positive, so positive, 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 positive. These are derivative graph points. And then to the left, to the right of 3, I have under the x-axis, so those are negative, negative. That means g of x is decreasing, and then it's increasing, and then it's decreasing. So we can say that g of x, because this is a question about g of x, not g prime, is increasing on the interval from 0 to 3 because g prime is greater than 0 on that interval. I'm just going to say on that interval from 0 to 3. Right? The reason that we know that g is increasing between 0 and 3 is because the derivative of g is greater than 0. It's positive between 0 and 3. And g of x is decreasing on x's that are less than or equal to 0 or x's that are greater than or equal to 0 because g prime is less than 0. It's negative, the derivative, on those intervals. I don't want to write them again, so I'm just going to say on those intervals that I just talked about. Are there any relative maxes and mins? Yes. G has a relative minimum at x equals 0 because g prime changes from negative to positive. And g has a relative maximum, and that occurs at x equals 3 because the derivative changes from positive to negative. So the way the derivative changes signs determines whether I have a relative minimum or relative maximum. But I wouldn't know that unless I looked at either my sign chart or look at my derivative graph. You don't have to do the sign chart, but if you got used to using a sign chart to determine where it's increasing, decreasing, where you have the relative mins and maxes, well, then you can translate the information that's in the graph into a sign chart, and the reasoning, the explanation will still be the same. We'll come back in the last video. We'll take a look at some more graphs that we can analyze.